The amounts of nicotine in a certain brand of cigarette are normally distributed with a mean of 0.947 grams and a standard deviation of 0.313 grams. We're going to find the probability of randomly selecting a cigarette with 0.509 grams of nicotine or less. So whenever you see the words or less, or you are asked to find the probability with the less than symbol, that means we want the probability to the left of that amount. So what I always start doing is draw my normal distribution and take note that the middle of that normal distribution is the mean that you're given. So when I want to find the probability of being less than 0.509, that means because 0.509 is less than my mean, it'll be somewhere over here on the left. All right, so what I'm going to do, I'll do this in a few different ways. First, I'm going to show you how to do this with the normal distribution table. And if I'm going to do that, I need to convert this 0.509 to a z-score. So a z is given by x minus the mean all over the standard deviation. So I'm going to plug in the x that I'm trying to find the probability to the left of, plug in the mean, and then plug in the standard deviation. Now plugging this into my calculator gives me about negative 1.4. So now I look at negative 1.4 on my normal distribution table, and that tells me the probability is about 0.0808. That is, the probability to the left is 0.0808, and that is the probability to the left of 0.509 when we're talking about x, but when we convert it to a z, that is the probability that z is less than negative 1.4, and that is what we found, 0.0808. Now, if we were going to do this in a spreadsheet, I would first do the same conversion. Z is negative 1.4, and now I can use the spreadsheet and the norm.s distribution to tell me what the probability to the left is. 0.08075, rounding to 0.0808. Now, as an alternative, if I didn't want to convert to a z-score first, I could actually use, as opposed to the norm.s.dist, the S stands for standard, but spreadsheets have a nice function. If you get rid of the S, it's a normal distribution. You just have to enter all the information about the problem. So the first thing is the same x that we converted to a z-score. So essentially, this is going to do all that conversion in the background without me having to enter anything. And notice the next thing it asks for is the mean. So that is 0.947. And then the next thing it asks for is the standard deviation, 0.313. And now this next one says, is it cumulative? For us, that will almost always be true. And that does a little better. The reason these two are a little different is because here, on the first calculation, the z-score was actually rounded to negative 1.4. If you actually plug the z-score into your calculator, you'll see it's not quite negative 1.4, a little off. And that means this is actually a little bit more accurate because they didn't round the z-score before they found the probability. In any case, whether we use 0.0808 or 0.0809, those should be close enough. Both should be awarded points. They're not far enough off to either one be wrong.